Hi, my name is Yu Zhang. Today I'm going to talk about the paper titled Predicting Multiple Metrics for Queries, Better Decisions Enabled by Machine Learning. This presentation will be divided into 5 parts. The first part will summarize the paper. The second part will talk about some related work. The third part will talk about the evaluation method. And the fourth part will talk about the work critic. In the last part, I will mention some improvements. So, what this paper talked about? It is well known that it's very difficult for people to know how queries will behave before they start executing. So the research problem the authors are trying to solve is how to predict multiple metrics for query performance efficiently and accurately. The authors propose using machine learning methods to predict these metrics and demonstrate the feasibilities of their approach using a real-world data set. So for the contribution, firstly, it provides a machine learning-based approach to predict multiple metrics for query performance. Secondly, the paper demonstrates the feasibility of this approach in real-world scenarios and highlights its scalability, making it a valuable contribution to the field. Here is a figure that talk about the high-level overview of the approach that designed in this paper. So firstly, it developed a standard system configuration. Then the author used the vendor to develop predictive models and tools. After that, those tools could be delivered to customers' instance to predict their query performance. So after the whole approach and do some and the experiments, the authors have several key findings. Firstly, they successfully predicted the individual query elapsed time with an accuracy of within 20% for 85% of the test queries. And besides, they accurately distinguished both the short and the long-running queries, provide valuable insights for managing workload and planning for capacity needs. I'm going to talk about some related work based on this paper. So there are four techniques I talk about in this paper. Firstly is query optimizers. Query optimizers use cost models to produce rough cost estimate for different query plans, but they do not easily map onto time units and are not sensitive to cardinality errors. And for the query progress techniques, they estimate a running query's degree of completion, use elaborate models and detailed runtime information, but do not predict performance before execution. And for the workload characterization, they focus on characterizing database workloads to validate system configuration decisions, but doesn't predict specific performance characterize. And for the last machine learning related techniques, this paper talks about some machine learning techniques to predict database performance. Use industry familiar techniques such as collimate statistical learning approach and PQR approach, which predict a relative cost estimate or ranges of query execution time, but not other performance metrics, which means that they just predict one metrics but didn't try to predict some other metrics. And after that, I want to discuss the difference between this paper's techniques and prior works. So firstly, unlike query optimizers, the model developed by this paper is based on the relative similarity of the cardinalities for different queries rather than their absolute value. This makes their model less sensitive to cardinality errors, and by contrast with query progress indicators, the work in this paper predicts performance before the query runs and doesn't require complete visibility into the number of tuples processed by a query operator. Lastly, by comparing with workload characterization techniques, This paper aims to predict actual resources usage or runtime and multiple performance metrics, not just a single metric or a cost estimate for use by the query optimizer. Before talking about the evaluation, I want to first talk about the experimental setup. The authors used the HP NeoView database system for their experiments. They had access to a 4 processor machine and a limited access to a 32 processor system, where they ran their queries on 4 different configurations with 4, 8, 16, and 32 processors. The data was partitioned evenly across all disks. The author then trained and tested their system using a variety of distinct workloads, including real customer queries and data, synthetic commercial benchmarks, and new templates based on real problem queries. They categorized their queries into 3 types based on the runtimes. Generating queries with appropriate performance characteristics was a difficult task, and it was hard to tell beforehand what type of query a given statement would be. So the author also used a set of customer queries against a separate production database for experiments where they wanted different schemas for the training and test size. So what is experimental method and techniques used in this research paper? The experimental method used in this research paper is to evaluate a number of statistical machine learning techniques for performance prediction in a database system. The techniques evaluated including linear regression, clustering techniques, PCA, CCA, and KCCA. The research paper compares the predicted and actual performance metrics such as elapsed time and records used for each technique and shows that regression models performed poorly. The paper then explains why clustering techniques and PCA are not suitable for finding relationships between query features and performance features. Finally, the paper described KCCA in detail and explained how it was adapted for database queries. KCCA was adapted for database queries because it is a generalization of CCCA, a CCA that replaces including dot products with kernel functions. This provides an expressive and computationally trackable notion of similarity, which is important in the domain of database queries. KCCA meets the requirements of researchers in finding relationships between two multivariate datasets, which represents query features available before runtime and performance features available after running each query. Critique, I want to first talk about the part that developed well and the part that didn't develop well. So for the part that developed well, the authors developed application of KCCA for predicting database query in performance. They showed that their model was more accurate than the query optimizer's cost estimation in predicting actual resources usage for many queries. They also explored the potential use of KCCA in investigating open questions in database engine development and identifying anomalous queries. What is more, they explored the possibility of continuous retraining for improved accuracy. For the part that didn't develop well, I think the author didn't discuss the potential drawbacks and limitations of their predictions, such as the fact that their predictions are limited to the range of performance metrics reflected by the training set, and that is computationally difficult to reverse KCCA's projection to determine which features are considered for each dimension. They also didn't mention any techniques to improve the accuracy of their predictions, such as techniques to reduce the impact of anomalous queries. Additionally, the author didn't describe how to make KCCA more practical for queries that take less than a second to run, which are not suitable for the current KCCA model. Um, for the part that I think could have been done differently, first is about predicting anomalous queries. It would have been helpful to have a more concrete method for quantifying the confidence of the predictions. It would have made it easier to identify anomalous queries and improve the accuracy of the predictions. And in terms of the speed of KCCA, it would have been beneficial to find ways to make the training process faster, as it currently takes a long time to complete. Techniques such as continuous retraining could have been implemented to keep the training set up to date and more efficient. And the next part is talk about something some part need additional justification. A comparison of the predictions with Curie optimizer cost estimate could help for this could be helpful to provide a more in-depth explanation of why the comparison between the predictions and the Curie optimizer cost estimate is unfair. This could provide more insights into the validity of the predictions. And for the next point is the contribution of features in performance prediction model. I think it would be beneficial to provide more concrete and detailed information on how each feature of test queries contributes to the prediction model. And a more detailed analysis could help to understand the importance of each feature and to improve the performance prediction model. For the method for capturing and quantifying the certainty of predictions, I think the initial result on the method for capturing the certainty of predictions need more explanation and justification, and a detailed explanation of the excluding distance method and its limitations could provide a better understanding of the validity of predictions. For the speed of KCCA, the explanation of the speed of KCCA could benefit from more specific details, such as the exact time required for prediction and training, and the conditions under which KCCA is considered practical, and the impact of the number of data points on training time. This could help to understand its practicality and limitations. In the last part, I will talk about some improvements. First is a follow-up to this study. As a follow-up to this study, I would suggest conducting a comparison experiment between the optimized query plans using the predictions made by the QCCA algorithm with the traditional plans. These experiments would help to determine the effectiveness of the predictions in improving the performance of the query plans. It would also provide valuable insights into the utility of the predictions in real-world scenarios. Additionally, the study could be extended to other complex systems such as map-reduced jobs and parallel computing environments, as mentioned in the long-term vision of the study. As for the ideas that I might want to explore, I think customize the feature vectors for each system and use domain-specific prediction models to answer what-if questions about workload performance would be helpful. And adapting the methodology to predict the performance of map-reduced jobs in various hardware and software environments could also help to improve the experiment results. And for the last section is to how to apply this experiment to real-world applications. The results of this study can be applied to real-world applications in the field of database management and parallel computing. The algorithm's ability to make accurate predictions about resources usage characteristics can help improve system sizing, capacity planning, and workload management. Thank you.